the permanent track monitoring of the Centenary Vitória Minas Railway, EFVM, which joins the cities of Belo Horizonte and Vitória in Brazil, managed under a concession by Vale, has been using a track geometry car, TGC, to assess its more than 2,000 kilometers of extension. Given the importance of the railway, and for improving the quality and safety of transport, Vale has implemented another technology to help survey the conditions of the road, the instrumented ore car, IOC. An inspection instrument still little known. Irregularities on railway track geometry, frequently caused by on-rail infrastructure issues, can result in undesirable movements on the train wagons, like twisting, rolling, bouncing, or pitch. Those movements can cause discomfort to passengers or instability of the cargo. In the worst scenario, derailments can occur. So, as soon as such problems are noticed, above a critical level, maintenance teams are notified. Meanwhile, speed restrictions at that spot must be set, which is very undesirable for the railway operation. Every voyage made by the IOC or the TGC results in a considerable amount of data that can help to localize possible defects. The use of big data analysis methods is mandatory, considering the volume of the information. This research will analyze the parameters, including the data collected by the TGC for road assessments. The use of these technologies allows the collection of data from inspection parameters of the track geometry in large volumes, with reliability and precision. Sensors aboard the IOC include triaxial and uniaxial accelerometers, GPS, load cells, and pressure meters. Data collection and transmission over the Wi-Fi or G3 networks occurs every second. Sensors aboard the TGC include several accelerometers, optical rail profile meter, tunnel laser, inertial measurement unit, and video camera for inspecting rails, sleepers, and fixtures condition. The preliminary data analysis has revealed a correlation among some of the parameters. In parallel, the team has compared data readings obtained near known points of failure of the railway, annotated by the operation teams of Vale. Those comparisons helped us propose a preliminary table for allowable values for sensor readings according to 3 grades of the operation. For each one of the grades, a recommendable action applies to the maintenance team. Named as severity indexes, those limits apply for each of the considered sensor readings. Severity indexes are currently under study by the research team to correlate their values with the right actions to be addressed to the maintenance team. In the second phase of the research, a series of machine learning experiments based on data collected by the IOC and the TGC will be conducted at the EFVM. The purpose of these experiments is to find adequate models for the assessment of the track geometry. With the correct identification and classification of such points, it will be possible to detect problematical segments of the railway, generating valuable information for the maintenance teams.